All right, page 5 of 2.4, we're talking about formulas and percents. And what if you're cruising along on these percent formulas, it's starting to come together, and then all of a sudden it's looking like a story problem. So I want you to start applying what we have been practicing in terms of story problems. You know you're in the section on formulas and percents, and you know that you just were getting really good at percents, whether you did A equals P times B from the book method, or doing what we were doing here in the notes, part over total equals percent over 100. It's just another way to think of how to set it up. Realizing that this is going to be the focus here, let's use our skills for solving a word problem here, and that is to read. Take a deep breath. Breathe in and out, and then read it again. Remind ourselves and search for what that goal would be. What is it they're asking us to do? Then we look for some keywords and info. We attempt to translate it to an order that makes sense. And then we go ahead and solve and do a look back to make sure what we ended up with matches to what the original words described. Okay, so let's read here. If 8 is decreased to 6, the decrease is what percent of the original number? Don't dive in. Take a deep breath. Read it again. If 8 is decreased to 6, the decrease is what percent of the original number? Okay, so that what percent kind of sounds familiar. That might be the only thing that sounds familiar, and that's okay, because that actually is our goal here. We want to come up with an answer that represents a percent, which then makes me realize I'm going to use my method of finding a percent. And for me, that's part over total equals percent over 100. You might have a different way. You might like the book way. A equals P times B, where B is your total, A is your part. So let's try to translate what they give us here. The percent problem is right here. The decrease is what percent of the original number. So here's our of, which means the original number is going to represent our total. Here's the percent. The percent is what we don't know, the x value. And so here's our leftover. The decrease is our leftover. This is our part. Okay. So let's look at what they give us here. What percent? So we have x over 100. We don't know what that percent is. Of the original number, so there's our total, the original number. The part is the decrease. Okay, well, that's great, except we don't know any of these numbers. That didn't get us anywhere. So let's look at the first part again. It says if 8 is decreased to 6. Okay, so it's going from 8 to 6. 8 represents our original number. Aha, now we know the original number. The original number is 8. Okay, now what else do we know? Decrease to 6. The decrease represents the missing piece that we don't have yet in our formula. The decrease is not 6. The decrease is actually 2. 8 minus 6 equals 2. 2 represents the decrease, how much it went down. So I'm going to put 2 right in here in our equation. So the decrease is what percent of the original number. If 8 is decreased to 6, 8 is our original number. It decreases to 6, which means the actual amount of the decrease is 2. So my decrease is 2, my original number is 8. If I look at the decrease, the 2 is what percent of 8 is what I'm really trying to find. 2 is what percent of 8. Okay, there's my word percent. They don't tell me what it is, so that's why x went over 100. I look for of. That tells me my total. So I took care of the what, the 8, the 2 is what's left, the leftover is our part. Okay. So now we are free to cross multiply. We've got one fraction equal to one fraction. So 2 times 100 equals 8 times x. So 200 equals 8x. Divide both sides by 8. Oops, I wrote x. Divide both sides by 8, and I will get x is equal to 25. And I was finding a percent, So I need to attach that. That's what's very important about when doing a look back. It's like, well, what did we get? If 8 is decreased to 6, the decrease 2 is what percent of the original number? I was trying to find a percent. That look back helped me remember that my answer needed to be in percent form. Sometimes I know for myself, if I forget, I can get kind of worn out by doing the actual math and kind of get a little distracted from what my goal was. So sometimes I'll actually, when I identify my goal, kind of estimate down the page to where I think my answer will be and remind myself with the label, or in this case the percent sign, to remind myself I've got to put that on my answer. Okay? And then you get to the practice plus. We're used to seeing what we just did in number 60 as a practice plus problem, but they throw it right in there as you're practicing your percent. So what are they going to give us for practice plus? Okay, I wanted to do this one together with you on the video because it has something that I think might throw some of us. It gives us a little bit of a pause. So I wanted to do it together, and that way you can just hit the ground running when you run into this on your own in the homework. Here's the instructions. Solve each equation for x. The equation they give us is y equals cx minus dx. So it's very similar to the rearranging of the formulas that we did from the beginning of 2.4. Okay, where we're solving a formula for a variable and there's no other numbers involved. There's all variables. Okay, so we're going to solve for x. The difference between this one and the one we've seen before is that x is in two places. You think, no problem, I'll just do the whole like terms thing. Okay, that's a great instinct. But we need to, well, how do we do that? We'd be used to it if it had numbers. Well, let's go through our little checklist here. When we're solving an equation, we check for parentheses, we check for like terms, we check that the variable that we're interested on has picked just one side to be on. Okay, there's no parentheses. There are like terms. They both, the variable we're interested in, x, they both have x. X has an exponent of 1, so exactly matching variables, exactly matching exponents. This is a situation where there are like terms that are involved here. Okay, so how do we combine that? Don't make up new math when it comes to algebra. When you're looking at algebra and you aren't sure what to do, give yourself a number example. Okay, what if I was looking at 5x minus 3x? Hopefully you would be comfortable enough and be convinced enough of the answer to that would be 2x. Well, let's look at why that is. It's almost as if we ignored x for a minute while we went ahead and combined the coefficients, the numbers out in front. Okay, so it's like we said, hey, I'll just do the 5 minus 3 and keep x out here to the side. It's kind of like we hold out x while we subtract the coefficients. And for one way to describe that is it's kind of like it's undistribution. It's reverse distribution. It's pulling that away from being multiplied by both while you deal with the inside. So in this case, we would say 5 minus 3, that gives us 2, again, then times x. Okay, so that was the y here, why that works. Well, let's do the same thing here. We want to combine these like terms, but I'm not really sure how to do that. Well, we can get part way there by saying, hey, let's hold x out to the side, just like we did here, and combine the coefficients, c minus d. And we can't get anywhere number-wise because we don't know c minus d, but it does allow us to move further in the process. It allows us to have one term here, something times x. Granted, it's a big something, it's in parentheses, but it is something times x. Now, the variable there's no other like terms, that's taken care of, and the variable does have one side. So now we can look at undoing what's happening to x. Well, what's happening to x? There's only one thing, it's getting multiplied by c minus d. So we just, or in this case, it's sort of a visual timeline here as you read left to right. Well, let's reverse that. Let's go up this list here. There's only one step, and we're just going to divide both sides by that c minus d. Or as you read right to left here, we're going to divide both sides by that c minus d. So let's do that. I'm going to rewrite my equation over here. Y equals c minus d times x. And let's divide both sides by it. On the right side, they cancel. That was the whole point, and I'm left with x equals y over c minus d. Notice the whole thing gets divided by that. And you could plug that back in and check if you wanted, but the back of the book is going to be sufficient for these. Y over c minus d is what happens when you solve that equation for x, or you can write it with x on the left if that's more comfortable for you, y over c minus d. So I wanted to walk you through that. You may have to rewind and watch this a couple times. The key is to understand what's happening with numbers and then apply that same thought process to the letters, because what works with numbers works with letters, because the only thing that you can do to letters is what you would be legally okay to do in the math world with numbers. Okay, you don't get to make up new rules just because we can't see the numbers anymore. They represent numbers. It has to still work when the numbers get plugged back in. So rewind that a couple times if you need to, and I'll see you at the bottom of the page for an example of an application exercise that you'll see in this section. See you there.